So hello guys, welcome back to my channel. So in this video we are going to learn about the linearity property and the first shifting theorem. First let's start into linearity property. Okay, linearity property is L of f of t is taken as f of x. We know this is the basic of, as I said in the previous video, this is the basic. Okay, this L of f of t can be written as 1 minute. So here we can write L of f of t is integration 0 to infinity e power minus t f of t dt, that is equals to f of s. So here we have taken this L of f of t is f of s, L of g of t is g of s. Then the linearity property, here it says if Laplace transform, if a of f of t and if you have b of g of t, okay, like this we have this, then now you have to separate it. Now we have to separate it, then you'll get L of a of f of t, L of a of f of t plus L of b of g of t. Now a and b are constants, so remove it. Okay, take it outside the bracket. Now it is a of L of f of t plus b of L of g of t. Now L of f of t and L of g of t is what? F of s and g of s. So write the values. L of f of t is f of s, L of g of t is g of s. So that is the property of linearity. Okay, so this is how we prove the property of it. The Laplace transform satisfies the properties of linearity. Okay, now let's go to first shifting theorem. Okay, yeah, here you see the first shifting theorem. If L of f of t is equals to f of s, okay, this is a basic function as I said, then L of e power at f of t is equals to f of s minus a. Okay, and L of e power minus at f of t is equals to f of s plus a. There's a lot trick I'll say here. You have at, right? A is positive, right? Then you have to take here s minus a, negative. Here a is negative, right? Then you have to take s plus a. So opposite, okay, opposite sense you have to take. That's a trick to remember this formula. This formula you have to remember at all costs because we are going to use it in many problems. Now see the proof. Okay, how to prove this? I'll tell later on how to prove sin 80 cos 80 formulas also, Laplace transform of sin 80 and cos 80. First let's just see this. L of e power 80 f of t. Okay, our general it is, you know, right? L of 1 minute. So this is the basic formula. I said this you have to remember. So this formula they used in this derivation. Okay, L of e power 80 f of t can be written as e power minus st, e power minus st. Now this e power 80 is exactly right, e power 80, then f of t dt. Now this we can write like this, e power, you take minus common. If you take minus common, then it will become s minus a of t, f of t. Now it became s minus a. See this, compare this formula. Okay, here if L of f of t integration 0 to infinity e power minus st f of dt, no, this can be written as how? F of s. Since here it is minus s, we wrote as f of s. Here it is minus of s minus a. So in place of s, we have to write s minus a. Okay, that's the logic. Now here L of e power minus 80 f of t, we have to write 0 to infinity e power minus st e power minus 80. Okay, same formula. Say here in place of e power 80, we have e power minus 80. And now you take minus common, if you'll take e power minus s plus a whole t f of t dt. So as you can see here, this is similar to this, but here we have only minus s, but here you have minus of, in place of s you have s plus a. So if it is f of s, this is f of s plus a. Okay, here you see here. Okay, this you remember. If it is L of e power 80 f of t, then it can be Laplace transform of f of t s tends to s minus a. So what you have to do while doing the solving the problems, you have to find this Laplace transform of f of t. After finding the f of t, no, if in the question if you have e power 80 Laplace transform of e power 80 f of t, no, then first you have to find the Laplace transform of f of t. Then you have to substitute the value of, in the place of s you have to substitute s minus a. And if the question is L of e power minus 80 f of t, then first you have to find the Laplace transform of f of t, then you substitute the in the place of s, you substitute s plus a, since here we have e minus at. So this is how you do, this is note. Okay, so in the next video I will explain a problem. Okay.